Linear equations are also known as first-degree equations, and by that we mean the power, right? The first-degree equations are the power of one equations, x to the first, y to the first equations. That's what we're talking about. So, what's the main key to solving those? If I have 2x plus 5 equals 7x minus 9. Just start off easy there. What's the main goal in solving a linear equation? Well, you've got to get x on the side by itself, right? So we need to get the x's on one side, the constants on the other, and that's ultimately on all equations what we want to do. Start off with an easy one here. Here's the way I picture it or write it down. You can use this way or whatever way you're comfortable with, but you need to get the x's on one side. I usually bring them to the left. We're going to subtract 7x both sides, and then move the constants to the other. So that would mean subtract 5 both sides. So I have negative 5x equals negative 14. Then I'd need to divide by negative 5. 5, so x equals, and then a negative divided by negative is a positive, which brings up the next point. That's usually the way they'll want the answers. Reduced fraction. If it can reduce it. Improper is the way they usually give it. You can write a mixed number if you like. What would that be as a mixed number? 2 and 4/5, or even 2.8, since it's a terminating decimal. All those answers I would accept. So just so you know. All right? But that's a linear equation, x to the first. Now, a couple of little notes on this one. This one's not too bad, but a couple of things to point out. Getting all that? Okay. All right, so on this one, what have we got to do? First step would be, what would be the first step? Distribute, yeah. A lot of times in mathematics, it's knowing the terminology and what to do and when to do it. In this case, the term is distribute, right? Distribute in the parentheses. You've got a 5 on the outside of these parentheses. You've got to distribute here. So we have 3x minus 2 equals, and then distributing means multiply. So I have 5 times x. And then 5 times 3 is 15. And then this one will come up a little bit too. On the outside here, I've got a minus. What's that going to do? That's going to distribute as well. You can think of it as it's a minus, but we can think of it as minus 1. So we have minus 1 times 4x will be minus 4x, and then minus times a minus gives me positive 9. Okay. Yeah, and that sign change right there, the plus 9 instead of minus 9, that's easy one to forget, but don't forget to distribute the minus there. All right, so then we have basically the same thing as we had before, just that we've got to combine the like terms on the right side. You got 5x minus 4x. 5 minus 4 gives you 1x. And then we've got 15 and 9 like terms there, so that'd be 24. Yeah, same thing as before. Get the x's on one side, constants on the other. So I need to subtract 1x and add 2. I do it all at once. Like I said, you can do it however you like, whatever makes you comfortable there. But I get 2x. Those go out, 26. Divide by 2, you got 13. So far, so good? Nothing too bad so far. Okay. All right. That's mainly, just covering a little territory here. Make sure we all got some things. One other thing, fractions. How to deal a little bit with that. Let's say we've got 2/3 x plus 3x equals 7/6 plus 5x. what to do about the fractions. Well, you can leave fractions in, but one other thought would be to get rid of the fractions, clear fractions. And the way we would do that is by using the LCD. The least common denominator. In this case, I've got, well, I just have two denominators, 3 and 6. And so the least common denominator, least common multiple of the denominators would be 6. Yeah. The other denominators are 1. So just take that least common denominator, 6, just the multiple that both of those go into, and multiply it by both sides. You know, that's the thing about equations is you need to do to both sides the same thing. That's the basic idea. Subtract the same thing, or add the same thing, or divide the same thing, or even you can multiply the same thing on both sides. So I'm going to multiply both sides of this equation by 6, which is, I'm going to multiply this by 6, and the other term by 6, because it's distributed, and then the other side by 6, or everything. Everything's multiplied by 6. And the reason I do that is because, notice, on the left side here, that means 6 over 1, what can I do? Well, that 3 and that 6, since I've got a 3 in the denominator and a 6 in the numerator, I can do some canceling, right? I can cancel the 3's out, 3 common factor of the 3 and the 6. That's going to put that at 1. Put that at 2. So I have on the top, I have 2 times 2x, that's 4x. What's the denominator now? The denominator is just 1. So I don't have essentially a denominator to work with. Okay? So I got rid of the fraction up front there. Now, in this term, I don't cancel out. It's just 6 times 3x. That's 18x. Then nicely on this term, since that's 6 over 1, don't the 6 cancel? Just becomes 1s. Both those become 1s. So here I have what? 7. And then 6 times 5x gives me 30x. So yeah, I go from fractions to one with no fractions, and that can be helpful sometimes. So that's what we recommend on those. All right, so what have I got? Well, I got 22x on the, because those are like terms. Yeah, all right, so subtract the 30x, negative 8x equals 7. Divide off the negative 8. I get negative 7/8. Sound okay? Everybody with me on that? Believe that? Okay. All right. Well, let's just go to on to our quadratics here. The second type I was going to mention today. Everybody got that one? Quadratics. Solving quadratic equations. A little bit about that. Now, the thing about quadratics is that quadratics, you might run into several different types of them that needs different solution methods. And what I mean by quadratic equations, linears were the first degree, x to the first, but quadratics are second degree. Yeah, x squared equations. We call them. Could call them. Yeah, the power, largest power we have is going to be second power. X squared, y squared, t squared. Whatever variable it is, it's squared. All right, so, like I said, there's several ways of solving these depending on the type of one you have. What if I have x squared plus 3x plus 2 equals 6? If you came across that one to solve, what would be your first inclination there? Get one side 0. Yeah. A lot of times on quadratics, you're going to want one side to be 0 because, well, there's a couple of methods that are hinging upon that. Yeah, so you need to make one side 0. A lot of times in quadratics that is the case. X squared then plus 3x minus 4 equals 0. Make one side 0. The way it looks looks like it's what we should do. All right, now, what do you think next? Well, that's there's two ways we could go with this one. This one actually, the preferred way of doing this one would be by factoring. Now we look at factoring. We've got one side 0. Let's see if we can factor the left side here, x squared plus 3x minus 4. Is that side factor? I believe so. It's a trinomial, the way I explain it. So I set it up, it factors into two binomials. You've got x squared, so that goes here and here. I break that up. X squared, that's pretty much x times x, so I'm going to break that up. What about the other two? Well, the other two come from the minus 4, don't they? How do I factor a minus 4? Well, there's just a couple of ways, but to get 3 in the middle, well, I need to factor it such that it adds to be 3, right? So that would be 4 and 1. And since it's a positive 3, it's a minus 4, positive 3. So minus 4 tells me one of them's negative, one of them's positive. And since it's plus 3, it'll be a positive 4 and a minus 1. Okay? So a little bit of factoring there. Yeah, and so if I FOIL that back out, it gets me the trinomial that I started with. Okay? Now what, though? Well, then, to get the actual answers, then two things multiplied together equals 0. Either your first one equals 0 or the second one equals. So you set each factor to 0, right? And then solve those accordingly. This is then just subtract 4 both sides. X is negative 4. And add 1 both sides on the second one, so you get x is positive 1. Two answers. Quadratics, that's usually what you need, two answers. With me on that little one right there. Okay? All right. A couple more there. So that's the first method to solving, call it the factoring method. We'll do a couple more on that. How that works. All right, so here's another one. 7x plus 4 equals 10 minus 3x squared. All right, a couple of points on that. First of all, of course, I need one side to be 0. And it doesn't make a whole lot of difference which side you want to be 0. In this case, I've got two terms on either side, so either way I go, I'm going to have to move two terms. But here's my recommendation is usually you'll want, if you can, the x squared term to be positive. So if I want the x squared term to be positive, which way should I go here? Move these terms, yeah, move these terms to the left. It's just simply because I want to make the x squared term positive. So I'm going to subtract 10, which is going to go nicely with the 4. It's a constant. Then I'm going to add 3x squared to both sides, which there's not an x squared term on this side, so if I put them in order, it's going to go in front. So I'll wind up with this. 3x squared plus 7x. Those aren't like terms, so they don't combine. 4 minus 10 does combine. That's negative 6. And then the right side would be 0. All right? Now, again, I prefer anyway this factoring method if I can, since I've got one side 0. Let's see, and there's different ways, if you know, different way you like to get those factored out, by all means use it. Here's the way I explain it. So now I've got 3x squared, so that's going to be 3x and 1x. And then I've got minus 6, which could be, it could be -2 and +3, or vice versa, -3, +2, or it could be -6 and +1. So I've got many options there. Let's say I go with this one, just to make a point. All right, so let's say I go with +2 and -3 in that order for -6. That may or may not be what I need, because I need it to, like I said, FOIL back to get that. And if I FOIL this out, here's what I get. 3x times x is 3x squared. 3x times -3 is -9x. 2 times x is +2x, and then 2 times -3 is -6. And those two will be the ones that combine. I get -7x instead of +7x. So you have to make some adjustments, try different things. This one isn't quite it. However, since it's minus instead of a plus, all I need to do here is change those over. And really, here's what the middle is what I need to check. This and this is 9x, and this is -2x. And as long as those equal what's in the middle, you're good to go. So, like I said, if you know other ways you like to do those, that's fine as far as factoring. But that is the way it factors. Okay? So factor that left side. Then what do? Well, we're not done. We've got to set them each equal to 0. And see what we get here. 3x minus 2 equals 0, so I'd add 2. So we get 3x equals 2, and divide by 3. Got 2/3. Here I subtract 3, and I've got -3. Again, my two answers that I should be expecting. Okay? Questions or concern on that one? All right. What about this one? 12t squared minus 20t equals 0. Is that one doable by factoring? Yep. Want to do factoring on that one. This one, actually, though, it starts out one side is 0, so all I have to do is think about factoring the left side. And how about would I do that? A type of factoring I haven't mentioned yet. What does this one have in it that the others haven't had? You always look for first in factoring a GCF. Yeah, greatest common factor. This one is GCF factoring. These two, since there's just two, we can, and well, it doesn't matter if there's three, or you do look for a common factor anytime, but these two do have a common factor, and the common factor would be, well, 4 would be a common factor, and t, wouldn't it? 4t would be a factor of both of those, all those on the left. Pull that t out front, and then you divide it out of each one of these terms. So what's left here out of the 12t? 12t squared. 3t? Yeah, it's dividing by 4. T squared divided by t is t. What about the last one? About 4t there, that gives me 5, or minus 5. Okay. So yeah, pull off the GCF and factor it that way. Well, once we get it factored, then we're to the same place we were over here. Equal to 0. 4t, set that equal to 0. 3t minus 5, set that equal to 0. Divide by 4, 0 divided by 4 is 0. 0 to add 5, and divide by 3. So I get my two answers right there. Okay? All right. Like I said, though, there's others that do call for a different type of solving method. And One of them is looks like this. Yeah, let's just start with that. Okay. On this one, the way we can go about thinking about this one, there's two answers here, and it turns out the two answers are positive 5 and negative 5. Now, how is positive 5 and negative 5 related? Well, turns out those are, aren't they, the square roots of 25, just positive and a negative of the square root of 25. So I like to think of this as a different method. What I basically did is I square rooted both sides. I just inserted also a plus and a minus, so I get my two answers, the plus and the minus 5. So I call that square root. Basically is square root both sides, but put plus or minus on the number side, in this case the right side. Okay, so what if it was x squared equals, let's just say, well, that one doesn't square root as nicely, but the answers are similar, aren't they? What are the answers here? If I square root both sides, I get x is the square root of 17. What's the other answer, though? Minus square root of 17. So I put a plus or minus there, kind of write them condensed version there. With me on that? Is that okay? One other quick note there, just to remind you. Y squared equals, what was I going to do? 32, I think. Yeah, 32. Same thing applies, doesn't it? Square root both sides, I get y equals the square root of 32, and it could be minus square root of 32 also, so it's plus or minus square root of 32. However, what do you note on the square root of 32? You can simplify it? Yeah, I can simplify this square root like I could the square root of 25 there, but not as nicely, I guess. But yeah, remember about simplifying square roots. There's a factor in there that I can simplify. Here's what I mean. Well, there's actually a couple I could do, but let's do 16 and 2. If I write square root of 32 as 32 is 16 times 2, so I'm going to basically split up the square root of 32. See what I did? Just factor 32 as 16 times 2, because what about that square root of 16? It's 4. So I get plus or minus 4 square root of 2. And that's a lot of times what they'll want you to do on such a ones as that. All right? Now, just to make a note here, 2x squared minus 90 equals 0. This sort of equation actually will come up a lot for what we're going to do. 2x squared minus 90 equals 0. Well, that's not quite in the same format as the ones we did there, the last few we've done with the square root method. However, can't I do this one with the square root method? What would I do to utilize the square root method on that? Move the 90 and the 2 to the other side, right? If I add 90 here and then divide by 2, so that would give me 2x squared equals 90. Then I divide by 2 and get my x squared. That would equal 45. That one also can be done with this square root method. Like I said, this will be something that comes up a lot the way we do it. So, and noting here that the technique is different. You know, on the factoring method, we want one side to be 0. On the square root method, you want the x squared equal a number. So it's a little bit different way of going about it. But so we've got x squared equals 45. So square root, both of those, and it could be a plus or minus square root of 45, but we can simplify that square root of 45. 95. 9 times 5 is 45, so we'll do the square root of 9, square root of 5, and the square root of 9 is 3. So we get 3 times the square root of 5. So yeah, make a note of that. That'd be a good way to do that one. Okay? All right, so we did factoring, we did the square root method. Well, if all those fail, there is one last resort.